All right. For those in the DC area, good afternoon. I'm calling in from Denver. So good morning to anyone on the central or further west time zones. I'm Brian Fox with Omni Federal. It's a pleasure working with ATARC to support this community and help spread best practices and interesting uses of technology and innovation, really to help the public users, folks in government, and other stakeholders accomplish better technical outcomes through the use of DevOps tooling, practices, and methods. Today, we've got Martin coming in from BAH. He's going to be sharing how they have been using AWS to meet the surge in camping popularity. So really how technology helped deal with some of the effects of COVID. The campsites and outdoor areas got really busy through COVID. So we're really excited about that. And just as a reminder, if you have anything you'd like to share from your agency or office, just reach out to me. I'm going to include my email address in the chat here shortly, so you can reach out if you're interested in presenting. Otherwise, also, this event is being recorded. We'll share this out on LinkedIn afterward. All right. Well, without any further ado, Martin, take it away.
Okay, great. Yeah, thanks for having me. As mentioned, we'll just kind of a quick talk on how Recreation.gov conquered the pandemic's early upshift in everyone's life. So I'll jump right in. So we'll talk quickly about what Recreation.gov is, and then we'll go through what kind of growth we saw from the pandemic, and then basically what are a few things that we use to get through that journey. So I've been with the project since its kind of inauguration, and before, as working the entire time as the site reliability engineer, leading that team for the group. So if you're not familiar with Recreation.gov, basically anybody can go today to Recreation.gov and you get a feel for what it does, at least from an external user's perspective. But we manage public lands, right? And so it's a one-stop shop officially for over 100,000 different call them assets. It's across a number of different agencies, and that number is always growing. So I think 7's actually a little bit out of date at this point. But lots and lots of agencies can kind of utilize the system to do their reservation management for all kinds of different types of assets. It's not just camping, which is the most popular one. So we do tickets for the Washington Monument. We do permits for backcountry things. We do passes, timed entry, as you'll see, all kinds of different ways that you can kind of make reservations with public lands and different experiences. Our journey started really in 2018. That's when the site went live. Of course, there was a long backstory from for how we came to that point, but that's kind of a talk for another day. This is kind of a quick experience. So there's just, again, two sides of it. If you log in today, you'll see the external side. You can search and look for different experiences. And then on the internal side, the site provides a way to manage those things and do all the things that you would expect the fields users need to do on a day-to-day basis to manage the different experiences. The interesting part of this talk is basically we went from having almost the lowest user traffic that the site has seen in probably a decade to double its peak in less than 2 months. And so that is certainly not a trivial task for most infrastructure and most architectures to take on in an effective way. And so there's two types of traffic that we see. One is kind of a consistent baseline traffic throughout the day, and kind of peaks around 3 or 4 o'clock, and then it goes away towards the evening hours, as people are kind of going to sleep and these kinds of things. But we also see single event traffic, right, where for things like Yosemite and these really popular locations, as soon as they go on sale, everybody wants to show up and participate in that release of inventory. So we saw huge spikes in both types of traffic, and both types of traffic required very different types of scaling and different responses from an architecture perspective to be effective economically. So how do we kind of make this all work, right? So one thing that you have to scale is people, right? That's really important aspect of this, just as important, or probably more important than the actual infrastructure side. And so we really take to heart this ability to make sure that people are dedicated to specific domains, and that they have a lot of ownership within their domains to do the right thing from a technology perspective. The best way to do this is to create an environment where microservices are the primary way that we build functionality throughout the system. And so while Recreation.gov looks like it's one big cohesive system, it's really not. It's made up of at this point over 70 different microservices. Each one of those is independently allowed to go to production whenever the developer feels confident they're ultimately in charge of that release cycle. So the product lead in this case, it's always a negotiation to say when is something done, but ultimately the developer, the team engineering lead, I'll say, is kind of at the helm for the quality perspective, as well as any of the other technical decisions there. Basically, this enables us to be very agile for new functionality, but also shifts in traffic where we need the services to be able to handle massive amounts of throughput increases or decreases from an economic perspective. And so we were able, with this architecture, we're able to individually provide exactly the right technical specifications for the increase in throughput for each of those services. And we can independently deploy them to production in safe ways. So within a few months, and this is just an example of the different services that are out there now. Within a few months, you can kind of see, we were able to implement a huge number of technical features, rate limiting and optimizations for different algorithms, et cetera, different feature flagging ideas, so that we could handle this huge spike of traffic that we were previously just not expecting at all. And I'll also mention that, so to be clear, each one of these represents a color of a different domain, but then each of the circles is a microservices, is a instance of a microservice. So, you can think of one team as being responsible for each of the different colors. Okay, so that's from a people perspective. So how about infrastructure, right? And so this is also super important to, again, be economical. So there's always the option of just creating a massive deployment of infrastructure to be able to handle that huge spike if you can predict it. And of course, in this case, we would have never been able to predict that we would see double the amount of traffic that we would get on any given year. We were used to seeing a slow increase in the amount of traffic we see on the order of 5, 10, 15%, these kinds of things. Not anywhere close to 100%. So there's, it's very unlikely that you'd be able to predict that. It's also very expensive to be able to go in and say, hey, I want to use, I need to be able to handle this amount of capacity when, you're not sure if you're going to get 0 or double for any given month, right? Which is what happened in the pandemic months. And so basically, we took a huge advantage of being able to scale our solutions using AWS technologies that enable us to scale across multiple different services, as well as utilizing a lot of different techniques to manage the scaling within those as well. So it's one thing to just kind of hand it over to AWS and say, okay, it's your problem now, you guys scale, but that's not always, it doesn't always work that way. So sometimes you have to do or manage the scaling yourself in smart ways. A good example of this is, for the types of events that I was mentioning before about Yosemite, where we go from baseline traffic to 4, 5, 6, sometimes 10x of baseline for minutes at a time while everyone logs in and tries to buy the same thing at the same time. AWS isn't going to predict that for you. You need to be able to define and pre-warm the infrastructure to handle that kind of rapid increase in demand. So we do this specifically these days with something called Kata, plus a cluster autoscaler. So these things are layered on top of Kubernetes, which is by itself a distributed system orchestrator, right? And so we provide this as a service to developers. So there's lots of complex things that happen to make this real. But from a development perspective, again, they own their domain. They know what's best for their domain, how to scale their particular services, what to expect from their different business areas and how they're going to grow and these kinds of things. And so we want to make it easy for them to make those decisions for us. We don't want to be in the driver's seat trying to understand all the different intricacies of how camping will scale on any given day. And so what we do is we just provide an interface for developers to basically put a little bit of YAML code, or as you can see on the screen, this is all that's required. So when does the scale need to start? When does it end? And how many replicas, or in this case, like how large amount of the scaling that you want to do, right? And so that's it. That's that, and they just put that in there, and you can kind of set it and forget it. We do all this in advance, and then the system will orchestrate and get all the necessary infrastructure to make the actual scale happen at the desired times. And so that was hugely important for us to be able to economically handle both zero load to start with, and then super high load. So we weren't, and when we were getting very little traffic, we were also spending very little money on infrastructure. And then immediately after things got popular, we were able to bring that right back up. Okay, and then the final aspect of this, which is a little bit unique to the recreation use case, or any kind of public-facing e-commerce type of system, and others outside of the e-commerce realm, but anything that has kind of significant public views and competitive locations or information, will have these kinds of problems. So we break this up into 3 different kinds of threat vectors. So we have folks that are scraping the site for basically just information about availability and other aspects of different camping or different inventory things. This isn't totally harmless because it's fairly expensive if people overdo it. We really prefer them not to do these kinds of things on the site because it messes with our infrastructure and how we can predict user behavior. Then we have cheaters, basically folks that are trying to take advantage of technology to give them an advantage in the release of inventory. People make bots to try and click faster and these kinds of things. And then malicious actors, which are folks that they're not interested in getting a ticket to Halakalea before anybody else. They just want to break the site. And so while there's lots of things we do for malicious actors, you can kind of think of this problem it's a little bit aligned for the other 2. So the solution that we have in place is to, and it's taken years to kind of mature to this point, but basically we do this kind of advanced observability and real-time feedback loops where we have static rules in place within our WAF solution that says, if you make so many requests to any aspect of the site within this period, you're probably not a person. You're probably either doing something nefarious or just you're going to take too many resources from the site from us than expected. And so we block them, but that's not always good enough. People get around it. This is always a cat and mouse game for all the different scenarios here. And so we do these much more advanced patterns and pattern analysis where we actually forward all of these WAF logs to Elasticsearch and Kibana, and then we apply custom behaviors. Where basically we look for behaviors that are anomalous and were destructive in nature, and then we can dynamically apply those rules to the WAF back. Outside of that, we also have our own specific service domain or service rules. So we can do things like, we're going to limit the number of active requests you can have in flight, how many requests you can make during a certain period of time for a specific action that might be different than this global rate limit, and then also hey, you've kind of overdo your stay. You've done a lot of nefarious things. We're just going to blacklist your account. Of course, all these things go to Splunk, and then we also do some other work with enterprise reCAPTCHA, integrating that to kind of work out some of the other bot attacks as well. Again, these are all very important for how we scale, because unfortunately, we have to do all this stuff so that we can focus and optimize the solution against actual people, and we're not being distracted by trying to build infrastructure or solutions for bots. And so we need to find a way to get, basically push those requests to the side and then focus on the requests that are actually providing real value to people, so we can make good technical decisions around that. Okay. So that's real quick breeze through of how we we were able to kind of go from 0 to 200 in just a few months during the pandemic. There's a lot of other stories and other aspects of both our culture and our technical stack that I think makes us made this a lot easier than it could have been if we weren't prepared beforehand to do this. But happy to answer any questions.
Martin, one of my questions would be just how well were you all prepared for that surge? Did all of this really come about and things went smoothly, or was there anything you had to really re-engineer or rethink based on how things actually performed? And then not only just performance, but there's always the cost, and government has learned so much as far as the use of cloud, in that there can be a bit of friction on really that user-centered focus, and that we really want the best performance within the budgetary constraints of the government entity, or in this case, entities supporting it. So just some questions about how it all worked, and then how you all, along with Park Service, BLM, and Forest Service, manage the budget of that surge?
Yeah, it's a great question. So one of the things I didn't mention, which I should have in the beginning, is that the recreation contract that we work under is very quite unique, or it's rare anyway. In that, so Booz Allen owns the actual system that provides all the functionality here, and we only recoup the cost of operating and developing that system through transactions that occur on or through the system. So whenever you make a reservation, there's a small portion of that goes back to Booz Allen, while the rest of it goes back to the parks or the agency that particular asset is under. So that definitely provides kind of this shared risk, shared reward environment, and it creates a lot of different types of budgetary conversations than you would traditionally have in some kind of cost plus or firm fixed price solution, where this situation would get very complicated very quickly, probably. And, if the system was never expected to handle double the traffic that it ended up seeing, 2 months after it saw zero traffic, there were significant hurdles that needed to get faced. How would the budget be able to respond to a spike in investment that was required? In this case, that conversation was pretty easy, right? We saw this increase, and we immediately were able to invest funds in order to provide or maintain the same, great customer experience that we have put kind of as an expectation over the years. So that's kind of the budgetary answer. And then the other half of the answer is like, did everything just work? And for sure, the answer is no. That's, I think it's important to kind of take away that the system just doesn't and most systems are probably not capable, at the scale, right? This is millions and millions of users. When you're talking about doubling that, most systems will probably fall over, if they were never designed for it. So, we had lots and lots of investment that we had to make very quickly in order to kind of maintain the throughput, right, in terms of rate limiting and the different experiences that the users have. So this whole hey, I'm going to click the button and then I'm going to get a modal panel, and then it waits for a little while, tells you what we're doing with your request, instead of just kind of clicking the add to cart button and then saying oh, it failed, sorry, try again. All these experiences needed to get revamped within that short time frame in order to maintain a nice quality of experience across the site, because things were just much more competitive. That still is the case. If you try and go camping today at a place that's fairly popular, you probably had a surprise when your favorite campsite is much harder to get than it used to be a few years ago. There was lots and lots of things that had to get built very quickly. So that's why and we had built that muscle over the years, thankfully. So that process of building things quickly and getting them into production quickly is just a part of the organization as a whole, and microservices and the platform that we've provided for the developers to do that, continuous integration, continuous delivery. We've been doing 5,000 deployments to production pretty consistently every year since we've gone live, and so there's lots and lots of small changes going to production every single day. And so that was that muscle of doing that provided us a huge platform to be able to meet this demand and get those changes we needed out quickly.
And that's probably one of the biggest lessons from your story, Martin, in this experience, is that the opportunity to be flexible, not just with cloud capabilities, but also the ability to adjust the platform and all those microservices to address everything you all were learning through that real world experience so rapidly. And like you said, in some cases, some systems might have fallen over with that kind of change, going from 0 to 60 or maybe 120 so rapidly. So that's really fascinating.
Yeah, absolutely. I mean, as the reliability engineering lead, I see this tension day in and day out, including within our own project and many others that I'm tangentially involved with, where when something bad happens, or if something risky is kind of in the foreground, people have a tendency to slow down and try and protect themselves by doing less, deploying less, making less changes, these kinds of things. I think it is very counterintuitive that what you actually want to do is go faster. That's not always true depending on your particular domain. There are more sensitive domains where there's caveats, but for the majority of different areas of the world, going fast is actually more reliable than going slow, and it's hard to fight that intuition.
Maybe that's a tagline to your presentation: speed is your friend.
Yeah, for sure. Yeah, and it takes it's a very much a cultural thing, right?
anyone else have any other questions? Any of the other folks in the audience? Otherwise, Martin, we're coming up on the end here of our time block. I would like to honor that. And Martin, thank you so much for coming in and presenting again.
Sure.
It was about 2 years ago, maybe 3 years ago, when you presented on what you all were accomplishing at BA. Or your story again, and how you worked through the COVID crisis and that surge in demand. So thank you again. And folks, we'll be meeting up again next month in July. So looking forward to that. Again, reach out to me if you'd like to present, and we should get this posted in the next few days to maybe a week onto YouTube. And we'll share that out on LinkedIn and get it out to you all. Martin, thank you again.
Awesome. Yeah, no problem. Glad to be here. Thanks for having me.